Dear students, having defined a discrete random variable and the distribution function of a discrete random variable, we now consider the mean and standard deviation of a discrete random variable. And the mean and standard deviation of a discrete random variable is identical to the mean and standard deviation of a population. Mean and standard deviation of a population. Now, for a variable x, the mean of all possible observations for the entire population is known as population mean. And we have defined it as mu as equal to sigma x by n. For population mean, the notation is mu. It is obtained by summing over all the observations of x, sigma x by n. Now, although this formula applies only to variables of finite populations, we can use it and the language of probability to extend this concept to any discrete random variable. This concept of mean is applicable to population, finite population. But using the language of probability, we extend this concept to any random variable, discrete or continuous. And in this section, we consider the mean and standard deviation of discrete random variable. Now, for a discrete random variable x, the mean denoted as either as expected x or mu. The mean denoted either as expected x or mu is defined as equal to, say expected x is equal to x1 into probability that x is equal to x1 plus x2 into probability that x is equal to x2 plus etc. plus xn into probability that x is equal to xn. And this is equal to x1 into f of x1 plus x2 into f of x2 plus etc. xn into f of xn. That is sigma x into fx. And xi, fxi, I is equal to 1 to n, or simply sigma fx. So the mean of the discrete random variable is denoted as sigma x into fx, where probability that x is equal to x is f of x1, f of x2, etc. f of xn. And to represent mean of a random variable, we use the word expected value. Expected value. The word expected value, expected x, expected value or expectation are used to describe the mean of a discrete or the mean of a random variable, whether it is discrete or a continuous. Now, if as an example, the random variable x is age, taking the values 12, 20, 21, 27, and fx is equal to 0.25, 0.375, 0.25, 0.125, then expected value of x is equal to 19 into 0.25 plus 20 into 0.375 plus 21 into 0.25 plus 27 into 0.125. The answer will give you expected x or expected value, also known as the mean of the random variable. The formula is sigma x into fx. And remember this quantity is always unknown because it is associated with the random variable. To calculate this quantity, we must have all the possible values of x and associated probabilities. And in inferential statistics, our aim is to make inferences about the expected value of x on the basis of a sample, on the basis of a given sample. And that is the essence of inferential statistics. Now, given the mean or the expected value of the random variable x, now let us define what is the standard deviation of the random variable x. Now, similar to the standard deviation of a population x, we define the standard deviation of a random variable x. Now let x is the random variable and expected x is equal to mu is the expected value of the random variable x. Then the spread of x around expected x can be calculated by the formula variance of x. The spread of x around expected x is calculated by variance x denoted by sigma square. You can add sigma square x or simply sigma square if you have no confusion about the name of the random variable is equal to expected value of x minus mu the whole square. Variance of x is a measure of the spread of the observations around the mean value, and it is simply the expected value of squared differences between x and expected x. It is simply the expected value of the squared differences between individual x values and its mean. So it is a average variation of individual x values, and as it is a squared quantity, it is always a non-negative number. It is always a non-negative number, and the positive square root of the variance of x is known as the standard deviation of x and is denoted as SDX equal to root of sigma square, that is sigma, is equal to root of expected value of x minus mu the whole square, root of expected value of x minus mu the whole square. And for calculation purposes, variance of x is denoted as sigma x minus mu square into f of x. For calculation, we use this formula, and this is the definition of the variance and the standard deviation. Remember this, in inferential statistics, our main concern is to make inferences about the characteristics of the population like expected value, variance, standard deviation, etc. These characteristics are known as the parameters of the population. And as the entire population is unknown to us, we have to make inferences about these characteristics using a sample. And statisticians have developed rules and procedures to make inferences about these parameters using sample quantities. And that is the essence of inferential statistics, and that is the subject matter of our classes and our course, how to make inferences about parameters using samples. And the population for our purpose is nothing but the random variable. Just as we use sample quantities to make inferences about population parameters, we use sample quantities to make inferences about the parameters of the random variables. And we consider population and random variable as one and the same thing, synonymous.